So the purpose of this short video is to illustrate the general idea of matrix elimination. So you get to a triangular matrix and then back substitution to solve for the variables one by one. And this might be a useful background for the video that Strang does, as you'll be watching for Monday. So let's say that we need to solve this system of equations. Two equations, here they are, and two unknowns, x and y. So you've learned in algebra classes lots of ways to do this. You can add and subtract combinations of each equation. One thing that you probably see right away that you could do is add the two rows together. The y's would cancel. You could then have an equation just for x, solve for x, and then go back and solve for y. But I'm going to illustrate a more systematic approach, one that works for all sorts of different systems. And this is what Strang does in his video as well. And this is important because it's a general algorithm for solving these systems, and it's the same algorithm that most computer programs use as well. So the first thing I'm going to do is I'm going to try to make this term, this 4x, go away. And to do that, I'm going to take this top equation and multiply it by 2, and then subtract that from this equation. So the top equation I'll leave alone. That's going to be 2x minus y equals 8. That stays put. Now I'm going to double this equation, subtract it from that. 4x minus 4x is 0. Y minus negative 2y is plus 3y. And then I take this 8, I double it, multiply by 2, I get 16. 10 minus 16 is minus 6. Okay, so at this point, these two equations are in what's called an upper triangular form. So there's a diagonal here, and everything to the lower left is 0. So I'll even draw that triangle in this sort of pink color. Here's the upper triangle. So in matrix form, you'll say this is an upper triangular matrix. Okay, so at this point, we've done elimination and turned it into an upper triangular matrix. And now these equations are easy to solve. We start with the bottom equation, we solve for y, and then we plug back into the top equation, and we can solve for x. So this process is called back substitution. So let's do it. 3x minus 6, 3y equals minus 6. That tells me that y better be minus 2. All right, now I have y. Let's plug that back into the top equation. 2x minus 2 is 8. 2x plus 2 is 8. 2x equals, let's see, 8 minus 2, that's 6. So this tells me that x will be 3. So we've solved the system. X equals 3, y equals minus 2. Okay, so again, just to be clear on the terminology, this process is called elimination. Elimination is adding and subtracting rows or equations from each other. We turn it into an upper triangular matrix. Then we do back substitution, start at the bottom, work our way back up to solve for the two variables x and y. Strang does this with x, y, z, so he does a 3 by 3 case, and he works directly with a matrix, so he doesn't write out x's and y's. So anyway, if you understand this example, nothing very deep going on, then you should be in a position to jump right in to Strang's video on elimination with matrices.